The live stream will happen momentarily. We're going to be going over some very important stuff. We're going to be looking at section 8.3. I don't think we spent much time on 8.3 yet, so people are still struggling with 8.3. We're going to talk more about 8.3. In fact, maybe we should even pull up some of the notes for 8.3 as well. Here's a question. In a Harris poll, adults were asked if they are in favor of abolishing the penny. Among the responses, 1,256 answered no, 488 answered yes, and 392 had no opinion. What is the sample proportion of yes responses, and what notation is used to represent it? So we know since it's a sample response, it's going to be p hat. So the answer is between A and C. And now we actually have to do this. We have to figure out how many said yes out of the total amount. We're going to need our calculator for this. I'm going to type in 1256 plus 488 plus 392. Now 488 said yes, divided by 2136. So I'm getting 0.228. I'm going to choose C for that. And a certain drug, well, I don't even have to read the whole thing. I can answer this one right now. Is the test two-tail, left tail, or right tail? In order for me to decide, I need to look at this. Because this says prop is less than 0.09, that means that it is a left tail test. The proportion is 0.09, and we're either going to test that it's not equal to, that it's greater, or that it's less. Because it's less than, we're dealing with the left side of the distribution. Lower than the mean. So that's the left side is lower than the mean, the right side is greater than the mean, and 0.09 is right smack in the middle. Go with left. What is the test statistic? Well, that's the z. They gave it to us, negative 1.75. It should be good. What's the p-value? The p-value is going to be 0.0401. That is right underneath the test statistic. What is the null hypothesis? Well, it looks like the null is that it's saying that it's less than 0.09. So, well, that's not the null. It's the alternative. The alternative has an inequality. The null has an equal sign. So the null must be H null, which is sub-zero. H null is defined as the proportion, or it's assumed that the proportion is equal to 0.09. It looks like the significance level is 0.01. That is not the p-value. 0.04 is not less than alpha. So we failed to reject because the p-value is greater than the significance level. These are just components that you have to get down and keep track of. What is the final conclusion? Well, there is no conclusion. There's not sufficient evidence to support the claim that less than 9% treated with headaches. The claim is the alternative in this case. Now there's two critical values. They're saying that the critical values is plus or minus. That means that it's a two-tailed test because we have two critical values. What is the test statistic? Negative 2.00. What is the p-value? 0.04. What's the null? Well, we really have to just understand the question. And we're talking about 36% of the adults, and we know that a null is always defined to be equal, has an equality symbol in there. So H null, A is the null hypothesis. Do we reject? Well, the p-value is 0.04, which is not less than alpha. So we fail to reject because the p-value is greater, just like in the previous problem. What is the final conclusion? There is not sufficient evidence to warrant a rejection of the claim. The test just simply fell apart. And there it is. Same problem, same type of problem. You have to set up the null and the alternative. A genetic experiment involving peas yielded one sample of offspring consisting of 438 green peas, 120 yellow peas. Use a 0.05 significance level to test the claim that under the same circumstances, 26% of offspring peas will be yellow. Identify the null and the alternative. Well, because they're saying that the claim is that it will be equal to this 26%, They usually mean that we're going to have to do a two-tailed test, which means the alternative is that it is not equal to 0.26. And therefore, now the test statistic, well, in order to figure out the test statistic, we have to do this problem on the calculator. So I'm going to do this on the calculator. I'm going to show you how you would conduct the hypothesis test on the calculator. This is going to be lifesaver on the statistical final exam. Just getting ready, cutting on the light. So you go into stats and then one prop z-test. We're dealing with 0.26. And then we also have to enter in the successes. 120 yellow. And then out of the total number of P's, well, we have yellow and green. So 438 plus the 120. My alternative is not equal to, hit calc, and it should give me my test statistic as negative 2.42 and also my p-value. So let's check it. My test statistic was negative 2.42. My p-value is therefore, if that's right, then our p-value should definitely be right. And then the question is, what is the conclusion about the null hypothesis? Well, let's compare it to the alpha, the significance level. Because the significance level is 0.05 and our p-value is 0.01, this is good. This means we actually have a conclusion. We get to reject the null now, because the p-value is less than the significance. What is the final conclusion? There is sufficient evidence to warrant the rejection of the claim that 26% of offsprings will be yellow, or there is sufficient evidence to support the claim so we're going to go with C. We have to reject this, and this was the null was the particular claim, and that's the end of that. So they're all kind of similar, just different contexts. I mean, if you keep looking on, if you look at on the next problem, a survey of 940 households showed that 142 of them use email. Use this sample results to test the claim that more than 15% of the households use email. Well, let's talk about this. So we're going to test the claim that 15% of households, 15% or more of households use email. So let's see what this proportion is. I mean, if that's about 15% maybe. Let's see, 142 divided by 940. That's a little bit above 15%. Is this enough evidence? Just because we're getting approximately 15.1% out of this sample that we did. We only sampled 940. So let's conduct a hypothesis test. Our null will be that it's equal to 15. The alternative is the one that we're going to test though. Is it greater than 15? And now at this point we will use our technology to get the test statistic and then also to get the p-value. Stat test 5 This is a right tail test. My p-value is not small at all. It's 0.46. My test statistic is 0.09. This is not, I can't reject the claim. It could be equal to 15%. This doesn't mean that it's going to be greater for sure. So let's finish off the rest of this. Our p-value is actually, hold on, that's our sample sample proportion. Our p-value is 0.4636. Oh, they want 3 places, they said? Okay, so 46, 4. Just 3 places, not 4. What's the conclusion? There is not sufficient evidence to support the claim that more than 15% of households use it. Is the conclusion valid today? Why or why not? You just can't make no decisions about the validity. But I will say this. As the future has changed, we probably could say so what they're saying is because and I don't necessarily agree with this, but what they're saying is that the conclusion is not valid today because the population characteristics of the use of email are changing rapidly. But that's the same as kind of you can't make no decisions, because if there's no conclusion, then I guess the conclusion is that you can't make a conclusion. But I guess B is the better choice, actually. I didn't read it carefully. No, it's not valid today. So we can conclude that it is not valid today. And the reason why is because the conclusion is not valid today because the population characteristics of the use of emails are changing rapidly. And we'd have to conduct a new hypothesis test in this time frame in order to make some sort of conclusion. But the truth is because the test fell apart, our results, we can't infer anything from our results. So that was a tough one. Okay, that was a tough one. That one got me. But I think there's a lesson to be learned in that one. So now I'm going to search for a harder one. I don't think this one's too hard. Let's see. The clinical trial was conducted using a new method designed to increase the probability of conceiving a girl. As of this round, 934 babies were born to parents using the method, and 863 of them were girls. Use a 5 significance level test to claim that the new method is effective in increasing the number of girls. So that means the alternative is greater than 50%. And then you would do the sample proportion would be 863 out of the total 934 babies. And this is very, very significant. I mean, clearly it's going to work out. So I'll let you do the rest of that. But you would do exactly what we've been doing. And then the p-value will definitely be less than 0.05. The p-value might even be close to 0. And sometimes the p-value is so small that they write it in scientific notation. We might see that here. Let me show you. Because that confuses a lot of people. We missed that. $863 plus is a nice sizable sample as well. 934, and that is the same. Okay, yeah, it's off the charts. The test statistic is 25 deviations from the standard normal mean. The p-value is just, let's just say 0. Yeah, the sample proportion resulted in a 92% rate of girls per birth. Let's leave that question. That one wasn't too tough. Same deal. This time they're talking about conceiving a boy. I demonstrated this particular problem. When testing gas pumps for accuracy, fuel quality enforcement specialists tested pumps and found that 1,287 of them were not pumping accurately, within 3.3 ounces when 5 gallon is pumped. All right, and 5,697 pumps were accurate. Use a 0.01 significance level to test the claim of the industry represented that less than 20% of the pumps are inaccurate. Okay, so we're going to do, it will be E for our null and our alternative. We're going to assume that 20% is the rate, and then our alternative will be less than 20%. Now, when we enter the information into our calculator, we're going to do our X value, or the probability of success, or the number of successes that were inaccurate, is 1,287 out of the total 5,697. So this is our N. And then our alternative will be that it is less than 0.2. And then you'll get your test statistic and your p-value. And then you will compare your p-value with a 1% significance level. If the p-value is less than 1%, you're good. If the p-value is greater than 1%, you're not good. The test falls apart. Just as what was demonstrated earlier. So you just probably have to understand the context of the problem. They're going to try to twisted all sorts of ways. But I think once you get the null and you state the null and the alternative, it pretty much guides you through the rest of the way. All right? So it's really about understanding the test and then understanding what are they trying to test. So let's try this one. Trials in an experiment with a polygraph include 97 results that include 23 cases of wrong results and 74 cases of correct results. Use a 1% significance level to test the claim that such polygraph results are correct less than 80% of the time. So since we're testing the claim that it's correct less than 80% of the time, we're going to set our null to be equal to 80% and the alternative to be less than 80%. And then after this point, what you're going to do is look at the number of cases that were wrong out of the total. And there was only 23 cases that were wrong out of 97. That's about 20%. That's very, very small. Okay? So you'll enter in that 23 for the x value, 97 for the n value. You'll get your test statistic. And you will also get the p-value, which would be super small. Let's keep going. Yeah, I think we looked at a particular problem like this. A 15 share, so on and so forth. See this? Use a 1% significance level to test a claim that more than 1/5 of people say the bosses scream. Well, 1/5 is 20%. And if we're testing that it's more than 20%, we have to set our null to be 20%. So I like B. And then the question is, well, what are we going to put for our x value? They didn't give us how many. They only told us the n. So what we'll have to do is do 26.9% of the 61,000 to get the x value. I'll demonstrate this. Go into test. Number 5. Wrong. Let's try that again. Stat, test, number 5. And we're using 0.2 as our null. Our x, we don't know quite yet, but what we'll do, x has to be a whole number. What we'll do is say, hey, 0.269 times 61,649. And then 61,649 for our n. Now I need to round this off. I'm going to round it off to 84. And my alternative is greater, so that this prop is greater than p null. Hit calc. Again, our test statistic is great. 42.83. The p-value, you could just put in 0. It is definitely less, since we will reject H null. There is sufficient evidence to support the claim that more than 1/5 of people say that their bosses scream. The conclusion is valid. Okay, hold on one second here. If the sample is voluntary response sample, the conclusion is may not be valued. All right, that's actually a good question, because one of the assumptions when conducting a hypothesis test is that you collect a random sample with less bias, but using a poll or a voluntary response sample, right away our data is flawed, it's skewed, and it does have a significant amount of bias. And so we cannot conduct a hypothesis test with a certain conclusion based on a voluntary response sample. So that was a tricky question, but I'm going to say that it may not be, and then that's it. Here's another one. I really like this one. I think what you should do for this one, since you need to know the sample, it probably is best to open it in Excel, and that's what some people did. You can click this and then click the little export button here, and you can open it in Excel. Let's see, let me open my Excel. Okay, so if someone wants to say, hey, what's the proportion of, say, green candies? What's the sample proportion of green candies? What I can do is say, well, there's 16 greens, so it starts at 2. So 16 greens out of the total number of candies that we're sampling. So we'd add them all up. 15 plus 23 plus 15 plus 16 plus 14. And that's what we'll divide by 16. And that's what you would enter into your calculator. Okay? And because we're testing the claim that it is 17% exactly, we'll do a two-tailed test. It's neither, the alternative is neither higher or lower. All right. We're going to wrap it up here. This should be a good review for the, for these, you should just look at your notes or kind of use prior knowledge, or maybe read the book, read this section of the book. It's only about 2 to 3 pages. And those answers will probably be contained in there for sure. Thanks for watching.